Hey guys, Mr. Bullock here again. This video is going to be just solving multi-step inequalities. I'm going kind of fast through these just so they don't seem long. So if you need to slow down, just hit the pause button, you guys. I tell my students to hit the pause so they can just write down the notes that they need to take care of. Okay, so let's begin. Okay, so we're going to go ahead and solve the inequality and then graph the solution set. Here's number one. Negative 7x plus 2 is less than negative 5. Okay, just like solving equations, we'd add out that 2 first, so subtract 2 on both sides. And you get, be careful you guys, negative 5 minus 2 is negative 7. I'm still getting kids tripped up on their negatives. Alright, and then when you divide by a negative, don't forget when you divide by a negative, it flips that inequality and makes it go in the other direction. And then you get x is greater than 1. Okay, and we know from our last lesson, you guys, here's the number line. Greater than means it's going to be an open circle at 1, and as long as the variable is over here on the left hand side, then this inequality tells me to shade it that way. It's pointing to shade it that way. Okay? Alright, so here's number 2. Okay, 1/3 quantity 3x plus 6 greater than or equal to negative 1. There's two ways to do this, and you'll find when you get into math, there's all kinds of ways to do. The higher you get in math, the more ways you can do it. And here's one way I'm going to show you. So if you multiply both sides by 3, it gets rid of that fraction because some of you guys are so fraction phobia, so let's get rid of it. So when you multiply both sides by 3, the fraction's gone, and you're left with 3x plus 6. And then over here, negative 1 plus 3 is negative 3. And then now we're going to subtract 6 on both sides. And we get 3x is greater than or equal to negative 9. And going to divide by 3, and you get x is greater than or equal to negative 3. Okay, remember, only you flip it when you're dividing by negatives, you guys, and we divided by a positive 3. So here we go. It's going to be, I'm going to show you another way first before we graph it, you guys. Another way is this, you guys. Since 1/3, I can take 1/3 of 3 easily, and I can take 1/3 of 6 easily. I can distribute that 1/3 through, and 1/3 of 3 is 1, and 1/3 of 6 is 2. So I think this is the quicker way if you can subtract out, or if you can distribute that through, no problem. Go ahead and subtract 2, and you get x greater than or equal to negative 3. See, I think it's faster this method if you can. But if I couldn't take 1/3 of one of these, and I'd go ahead and do the first method and multiply out. All right, and then so it's going to be a closed circle on negative 3, and it's going that way. Okay, here's number 3. 14x plus 5 less than 7 times the quantity 2x minus 3. All right, let's go ahead and distribute that 7 through, you guys. So I get 14x minus 21 on the right hand side, and then on the left it's still 14x plus 5. Okay, going to subtract out 14x on both sides. Something weird happens, you guys. I'm left with 5 on the left and negative 21 on the right. And you have to think about this. Is 5 less than negative 21? Of course not. So what happens there, when it's a false situation, then you say there's no solution. All right, so if you get an inequality in a goofy situation like this, if it's a false case, then the answer is no solution. And how do you graph a no solution? You just graph an empty number line, you guys. That means there's no solution on that. So just draw an empty number line with no shading. Okay, here's number 3, or 4, sorry, the last one. Okay, 12x minus 1 is greater than 6 quantity 2x minus 1. Go ahead and distribute that 6 through, and you get 12x minus 6 on the right. Okay, and just like last time, when you subtract 12x on both sides, the 12x's cancel, and you're left with negative 1 is greater than negative 6. Okay, negatives kind of work backwards, you guys, and you can think of negatives like money. You know, negative 1 is like you owe $1, you're $1 in the hole, and negative 6 is negative $6 in the hole. I think negative 1 is a better situation, a greater situation, hint, 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 than negative 6. I'd rather have only $1 in the hole than $6 in the hole. So that's a true case, you guys. Negative 1 is greater than negative 6. Negatives work backwards, you guys. So when when that happens, then it's all real numbers. Okay, and how do you graph all real numbers? You shade the whole number line. All right, I hope that helps you guys.